Welcome to MS 100 lessons, and in this lesson I'll be doing a past paper on Newton's laws. So I'll start by reading the question and then we perform our analysis using the steps that we follow in MS 100. So I'll start by reading the instruction. The instruction says a learner construct a push toy using 2 blocks with mass of 1.5 kg and 3 kg respectively. So we can see that we have mass of the first object and we have mass of the second object, right? So we can calculate Fg for this object, which is the 1.5 kg, okay? And we can also calculate Fg for the second object, right? So Fg for the 1.5 kg block, that is equals to mg, which is 1.5 multiplied by 9.8, okay, and that would be 1.5 multiplied by 9.8, and that will give us 14.7 newtons downwards, right? So that is our gravitational force for the 1.5 kg, and then our gravitational force for the 3 kg, okay, that would be Fg equals to mg, right? And the mass of the object is 3 multiplied by 9.8, right? So that would be 3 multiplied by 9.8, and that will give us 29.4 newtons downwards, right? So this is our calculation from the statement. Okay, so the blocks are connected by a massless inextensible cord. Okay, so the fact that we have an inextensible cord, it means we will have tension in that cord, right? So the learner then applies a force of 25 newtons at an angle of 30 degrees to the 1.5 kg block by means of a light rigid rod, right? So it means there is a force which is applied on the 1.5 kg. So that is your applied force, which is 25 newtons, right? And it is applied at 30 degrees from the horizontal, right? So they said it is causing the toy to move across a flat, rough. The fact that there is a rough horizontal surface, then it means we have frictional force acting between the surface and the object, right? As shown in the diagram below. So they say the coefficient of kinetic friction, right, between the surface and each block is 0.15. So it means the coefficient of kinetic friction between the 3 kg and the surface is 0.15. Same thing applies to the coefficient of kinetic friction for the 1.5 kg, which is 0.15, because they said for each block, right? Okay, so now we have to perform our analysis using the steps that we follow without looking at any intermediate statement from the question, right? So let us perform our steps to analyze this question. So our analysis, remember you always have to analyze the question before you start answering, right? So our analysis for step number 1, we said we separate, okay? So when we separate, it means we will be applying Newton's laws on this object and Newton's laws on this object separately, okay? And then step number 2, we draw our free body diagram for each object, right? We draw the free body diagram for the 3 kg and we draw a free body diagram for the 1.5 kg. And then step number 3, we resolve any forces which are not in the x direction and the y direction. So in this case, the system of axis that we will be using, right? The system of axis that we'll be using will be that y-axis and the x-axis, right? So any force which is not in the y direction or that x direction will be resolved, okay? And then the next step after resolving is to perform your F net in the y direction. Okay, why do we perform the F net in the y direction? So that we can obtain our normal force, and after obtaining the normal force we can obtain our friction for that object, right? And then step number 5, F net in the x direction. Okay, and then the last step is to solve any unknowns. All right, so let us start with step number 1. We separate the object, right? So we agreed that we're going to be applying Newton's laws on this object separately. Okay, and then step number 2, we draw the free body diagram for the objects, both objects. So let us start from step number 2. Okay, all right, so step 2, the free body diagram. Let us draw the free body diagram for object number 1, which is the 3 kg. Okay, so we have free body diagram for the 3 kg and a free body diagram for the 1.5 kg, right? So now let us start with the 3 kg. So with the 3 kg, looking at the 3 kg block, we know that we have Fg because we have mass, right? And Fg is acting downwards. And since it is on a surface, there is a reaction force from the surface, which is your normal force, right? Going upwards. Okay, and you can see that there is a string which is pulling the 3 kg block. Then it means there will be tension which is acting to the right. Okay, and then since this object is moving, or these objects will move to the right, then it means your friction will move to the left. Okay, because they said here in the statement, they said the applied force is causing the toy to move across a flat, rough, horizontal surface, right, as shown in the diagram below. So it means if you apply a force in that direction, then they will move in that direction to the right. So it means friction will be to the left. Okay, so let us draw all those forces in the 3 kg free body diagram. We have Fg, right, going downwards, and we have normal force. Okay, normal force going upward, and we have tension, which is pulling that object in that direction, and we have friction, which is opposing the motion, right, or opposing the direction of motion. So that is the free body diagram for the 3 kg. So now let us calculate, or let us do the free body diagram for the 1.5 kg. So if you look at the 1.5 kg block, right, we can see that we have the mass of the object, then it means we have gravitational force. We have the surface, we should have a reaction force for the surface, right? We have tension, which is pulling back this 1.5 kg, then it means there will be tension acting to the left. Okay, and remember the surface is rough and this object is moving to the right, so it means we have friction that is pointing to the left. Okay, and we also have that applied force in that direction, which is 30 degrees from the horizontal. Okay, so now I will indicate all those forces that I've just discussed in this free body diagram. I said we have weight, which is downwards always, and I have my normal force, which is upward, right? And then I have my tension, which is pulling back the object, right? And I also have my friction, which is opposing the direction. Okay, and now we also have the applied force, right? Remember, the applied force is applied in that direction. Okay, and that which is 30 degrees from the horizontal. So we can also draw this applied force starting from the free body diagram, right? We draw it like that. So that would be our applied force, and remember this is our horizontal. Okay, and as you can see that this angle would be 30 degrees since opposite angles are equal. Okay, so that is our free body diagram for the 1.5 kg. So that was step number 2. So let's go to step number 3, which is resolving. Okay, so when we resolve, we have to check the forces which are not in the x direction and the y direction. All right, so we look at the free body diagrams now. looking at the free body diagram for the 3 kg, you can see that the normal force is in the y direction, okay? So there's no need to resolve the normal force. And the Fg is in the, Fg is in the y direction, and you have tension which is in the x direction, friction in the x direction. So there's no need to resolve any force in this free body diagram. So now let's go and look at the free body diagram for the 1.5 kg, okay? So you have normal force in the y direction, tension in the x direction, right? Negative x direction, friction in the negative x direction, Fg in the negative y direction. Okay, so there's no need to resolve these forces. But looking at F applied, so F applied is applied at an angle of 30 degrees from the positive x axis, right? Which is clockwise from the positive x axis. You can see that that is 30 degrees. So it is not applied in the x direction or y direction. So we have to resolve this force, right? So when we resolve the applied force, we will have two components, okay? We will have the x component and the y component. So that is Fa y and Fa x, okay? So now we have resolved our applied force, okay? So by calculation, remember when you resolve, you also have to calculate your components. So in the x direction, that would be F cos theta, okay? And your Fay, that would be F sine theta. So now, when you go back to the instruction, they said your applied force is 25 newtons, right? So this would be 25 cos, and your angle was 30 degrees, okay? And now this one would be 25 sine 30. So that would be 25 cos 30, and I am getting 21.65, right, newtons. And 25 sine 30, which is Fay, I'm getting 12.5 newtons, okay? So we are done now with step number 3, which is resolving our forces. We have resolved the applied force, which was applied 30 degrees from the horizontal. Okay, so step number 4, we go to F net in the y-axis. And the main reason why we do this step is because we want to calculate the normal force and the kinetic friction, okay? So step number 4. So step number 4, let us apply then F net equals to MA in the y-axis or in the y direction, okay? So in the 3 kg block, how many forces do we have in the y direction? We have 2 forces, okay, which is normal force, which will be positive, and Fg, which will be negative. Because remember, the system of axis that we are using the positive x-axis, negative x-axis, right? Negative y-axis and positive y-axis. So normal force will be positive because it is pointing upward, and Fg will be negative because it is pointing downwards. So we have normal force, which is positive, Fg, which is negative. We have 2 forces, and that is equal to the mass of the object multiplied by acceleration. But as you can see from this diagram, the objects are moving to the right, okay? They're not moving in the y direction. So acceleration in the y direction is equal to 0. So that would be mass multiplied by 0, and then normal force minus Fg, that is equal to 0. So your normal force is equal to Fg, right? And we have already calculated Fg for the 3 kg up there, and Fg for the 3 kg is 29.4. So we have 29.4 as our normal force, okay? And remember, immediately after this, you calculate your friction, because those are the aims for performing your F net in the y direction, is to obtain the normal force and then you obtain your friction. So let us calculate the friction, which is Fk equals to the coefficient of kinetic friction multiplied by the normal force. So the coefficient of kinetic friction, it was given as 0.15 for both objects, right? So that would be 0.15 multiplied by the normal force, which is 29.4. And our friction would be 0.15 multiplied by 29.4. That would be 4.41. So that is the kinetic friction between the surface and the 3 kg block. Okay, so now we are done with the F net in the y-axis for the 3 kg block, and let us perform the y net force for the 1.5 kg. So that would be F net in the y direction, F net equals to ma, and the net force in the y. How many forces do we have in the y direction? So in this case we have 3 forces, right? We have the normal force, which is positive, okay, and we also have Fg, which is negative because it is pointing downwards. We also have the component of the applied force, which is Fay, which is negative because it is pointing downwards. Okay, so now we have 3 forces in the y direction. So we have the normal force, which is positive. We have Fg, which is negative, and we also have the component of the applied force, which is negative. Okay, that is equal to the mass of the object, and the acceleration of that object in the y direction is equal to 0. So you have your normal force minus Fg minus Fay equals to 0. But now you have calculated your Fg, which is gravitational force for the 1.5 kg up there, to be 14.7, right? So we insert, or we substitute 14.7 for Fg, and Fay you have calculated it in step number 3 where you were resolving. Fay was 12.5. Okay, so we have 12.5 equals to 0. Now that would be normal force minus, if you add negative 14.7 minus 12.5, you get negative 27.2 equals to 0. So now our normal force for the 1.5 kg, we have 27.2 newtons. Okay, so now after obtaining the normal force, we can calculate our friction for this object, and the friction for this object would be the coefficient multiplied by the normal force. Okay, and the coefficient is the same for both objects, which is 0.15. So that is 0.15 multiplied by 27.2, and our frictional force would be 0.15 multiplied by 27.2, and our answer is 4.08. Okay, so that is our kinetic friction for the 1.5 kg. All right, so we are done with step number 4, whereby we obtain the normal force and the frictional force using the F net in the y-axis. So now step number 5, you apply your F net in the x-axis now for both objects. So let's apply the net force in the x-axis for the 3 kg. So step number 5, F net in the x-axis, right? For the 3 kg, that would be F net equals to ma. So let us check how many forces are acting in the x direction for the 3 kg. So for the 3 kg, you have tension, which is positive, okay? And then you have friction, which is negative. So now that would be tension minus friction. That is equal to the mass of the object multiplied by the acceleration. But remember, acceleration is a vector, so you have to substitute the direction of that acceleration. And since these objects are moving in that direction, so the acceleration would be positive. So that is positive a. Okay, so that would be tension. Remember, we have calculated friction from step number 4, F net in the y direction, to be 4.41. So that is 4.41 equals to the mass of the object, which is 3 kg, multiplied by the acceleration of the object. So that is equation number 1, because we have two unknowns. So now let us perform the F net in the x direction for the 1.5 kg. So that would be F net equals to ma in the x direction. Okay, so how many forces are acting in the x direction for the 1.5 kg? We have three forces from the free body diagram. Okay, we have Fax, which is the component of the applied force in the x direction. We have tension, which is negative. We have friction, which is negative. So our equation will have Fax minus tension minus friction, and this is equal to the mass of the object multiplied by the acceleration. Remember, acceleration is a vector. You need to substitute with the direction, and since this object is moving to the right, then it means your acceleration would be positive. So that would be positive a. So remember, Fax you have calculated in step number 3, where you were resolving the applied force, which is 21.65. So you substitute 21.65 for Fax. Okay, and then we have tension, which we haven't calculated, and we have friction. And friction, we have obtained it in step number 4, whereby we were calculating the F net in the y direction, which is 4.08. 4.08, that is our kinetic friction for the 1.5 kg. And the mass of the object is 1.5 multiplied by the acceleration. Okay, so if we can collect like terms here, we'd say 21.65 minus 4.08, that would be 17.57 minus tension equals to 1.5 a. So that is equation number 2. So we are done with step number 5. So step number 6, you solve any unknowns. As you can see, we have two equations now. We have equation number 1, whereby the unknown is tension and acceleration, and we also have equation number 2, whereby the unknown is tension and acceleration. So we have to solve these two variables simultaneously. So from equation number 1, if we can make t the subject of the formula to get equation number 3, and then we substitute this equation number 3 in equation number 2. Okay, so that would be 17.57 minus, wherever we see tension, we insert 3a, plus 4.41, and that is equal to 1.5 times the acceleration. Okay, so now let us solve for acceleration in this equation. So this would be 17.57 minus 3a minus 4.41 equals to 1.5a. Okay, so let's take this 3a to the right hand side, and what is left is 17.57 minus 4.41, and that would be 13.16. That is equal to 1.5a plus 3a, since it was negative this side. So that would be 13.16 equals to 4.5a. Okay, and then we divide both sides by 4.5, divide by 4.5. So our acceleration, we get 13.16 divided by 4.5, and our acceleration is 2.92 meters per second squared, and this acceleration is to the right. Okay, so that is our answer for the acceleration. So now let us calculate the tension. tension would be equal to 3, and then the acceleration is 2.92 plus 4.41. Okay, so the tension is equal to 3 multiplied by 2.92 multiplied, plus 4.41, and that would give me 13.17 newtons. Okay, so that is my tension. All right, so we are done with our analysis. Let us look at the questions now. Question 2.1, it says, state Newton's second law in words. So Newton's second law in words, it states that when a net force is applied on an object, when a net force is applied on an object, the object will accelerate. The object will now accelerate, and it will accelerate in the direction of that net force. So it will accelerate in the direction of the net force. And the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. To the mass of the, so that is 2.1. And then 2.2, calculate the magnitude of the kinetic frictional force acting on the 3 kg block. Okay, so from our analysis, we have calculated the friction acting on both objects, and the question is only requiring the frictional force on the 3 kg block. Okay, so from our analysis, where did we obtain our Fk for the 3 kg block? Step number 4, which is F net in the y direction. Okay, so this is your working. So this is 2.2. So I can just write that 2.2 is from analysis. Okay, and then draw a labeled free body diagram showing all the forces acting on the 1.5 kg. And remember, a free body diagram is step number 2 in our analysis. Okay, so this is the free body diagram. Remember, you can also draw the free body diagram before resolving. So this is the free body diagram. So that is 2.3. So we can also say this question is from analysis. For the 1.5 kg. Okay, and then 2.4, calculate the magnitude of the kinetic frictional force acting on the 1.5 kg. So the kinetic frictional force, we also obtained it in step number 4, F net in the y direction. So this is the kinetic frictional force for the 1.5 kg. Okay, so this is 2.4, and we can also state that this was from analysis. And the last question, determine the tension or calculate the magnitude of the tension in the cord connecting the two blocks. And we have calculated the tension down here in the last step whereby we were solving, and this started from the F net in the X direction. So all this working, okay, all this working gave you the tension, and we have calculated our tension to be 13.17. Okay, so we can also say that this question, we've answered it from our analysis. So if the question further said calculate the acceleration between the two, the acceleration is also on the analysis. So you can see that the analysis has answered all our questions that they were requiring us to calculate in this question.